Space-based astronomy has revolutionized our understanding of the universe. By escaping Earth's atmosphere, astronomers have been able to observe celestial phenomena in unprecedented detail across the electromagnetic spectrum. This video explores the history of space-based astronomy, from early concepts to modern space observatories, and discusses their impact on our knowledge of the cosmos. Before space-based observatories, astronomy was conducted exclusively from Earth. The invention of the optical telescope in the early 17th century allowed scientists like Galileo Galilei to make groundbreaking discoveries. However, Earth's atmosphere presented significant challenges. Light pollution, atmospheric distortion, and absorption of various wavelengths limited the effectiveness of ground-based telescopes. As early as the 1920s, scientists like Hermann Oberth and Robert Goddard speculated on using rockets to place telescopes beyond the atmosphere. The idea gained momentum in the mid-20th century as technology advanced and the space age began. The launch of the first artificial satellite, Sputnik 1, by the Soviet Union in 1957 marked the beginning of the space age. Although Sputnik itself was not an astronomical instrument, it demonstrated the feasibility of placing objects in orbit. Soon after, the US and Soviet Union began considering astronomical applications for satellites. In 1962, the United States launched the first space-based astronomical observatory, the Orbiting Solar Observatory, OSO-1. This was followed by a series of other orbiting solar observatories designed to study the sun's ultraviolet and X-ray emissions, which are blocked by Earth's atmosphere. During the 1960s and 1970s, several key space-based observatories were launched. NASA's Orbiting Astronomical Observatories, OAOs, provided some of the first detailed ultraviolet observations of stars and galaxies. OAO-2, launched in 1968, made significant contributions to understanding stellar atmospheres. The Soviet Union also developed space-based astronomy with missions such as the Prognoz satellites, which focused on solar physics and cosmic rays. Additionally, the Uhuru satellite, launched in 1970, became the first X-ray astronomy satellite, leading to the discovery of numerous X-ray sources, including black holes and neutron stars. The 1980s saw major advancements with missions like the Infrared Astronomical Satellite, IRAS, launched in 1983. This was the first space telescope dedicated to infrared astronomy and led to the discovery of thousands of infrared sources, including protostars and distant galaxies. Another milestone came with the launch of the Hubble Space Telescope in 1990. Though initially hampered by a flaw in its primary mirror, a 1993 servicing mission corrected the problem. Hubble has since provided some of the most detailed images of the universe, deepening our understanding of cosmology, galaxy formation, and exoplanet atmospheres. The 21st century has seen an explosion of space-based observatories operating across different wavelengths. The Chandra X-ray Observatory and the XMM Newton have greatly enhanced X-ray astronomy, uncovering details about black holes, neutron stars, and supernova remnants. Infrared astronomy has been further revolutionized by the Spitzer Space Telescope and the James Webb Space Telescope, which have provided unprecedented views of the early universe and planetary systems. Radio astronomy has also entered space with missions like the Russian Spectre-R and upcoming projects such as the Square Kilometre Array, which will have a space-based component. Space-based astronomy has transformed our understanding of the universe. From early ideas and crude satellites to sophisticated observatories like Hubble and James Webb, each mission has contributed to unraveling cosmic mysteries. As technology advances, future telescopes will continue to push the boundaries of what we know about the cosmos, ensuring that space-based astronomy remains at the forefront of scientific discovery.